Hello everyone. Today in this lecture we will study about informed search algorithms. Informed search algorithms are a major part of artificial intelligence. We will discuss in detail further in the upcoming slides. Now these will be the topics that we will cover in this lecture. First is informed search algorithm, then we have heuristic algorithms, then there is A star algorithm, then we will study the step by step process for A star algorithm, then we will look into some examples and the detailed working of A star algorithm. Now first, what is informed search algorithm? Informed search algorithm are such type of algorithms that use additional information, often called a heuristic, to guide the search process. Now what is heuristic? Now informed search algorithm use heuristic knowledge to improve search efficiency. Using heuristic, we are improving the search efficiency. Heuristic is the estimated value from starting node to the goal node. Okay, now a heuristic provides guidance by estimating the cost from current state to the goal state. One of the major examples of informed search is A star algorithm. Now let's see some key features for this algorithm. First is the heuristic function. This is the major key term in this informed search algorithm, that is a heuristic function. Heuristic function is an estimated cost to reach the goal node n. This goal node can be anything. It is also faster than the uninformed algorithm. It uses additional problem specific knowledge. Okay, let's see further. Now, what is a heuristic function? In this informed search algorithm, we are given information about the goal state. Whereas in uninformed search algorithm, we have no information what the goal node is. Suppose we have a starting state. We have to go to a goal node. In the informed search algorithm, we will be given information about the heuristic node. Whereas in uninformed, there is no information to go. Suppose we have to go via this node and no information is given. So there will be a it will be a time taking process. Okay, so the next point is it finds optimal set to reach goal state. Now the next set is minimum path of the cost using heuristic function is required. Now it is a search which tries to reduce the amount of search that must be done by making intelligent choices for the nodes that are selected for expansion. That means it will be saving us a lot of time by not doing unnecessary search in depth. Suppose we are given the distance 1, suppose it is 2 and it is also 1. Suppose we have to reach from the starting node to the goal node and the distance to go from this path is 1 plus 2 is 3 and this path is 1. So we will be choosing the minimum value. We will be choosing this path. We will go through S direct to the G. So it will be making some intelligent choices from going to the starting node to the goal node. Now, what are heuristic algorithms? Now, the term heuristic helps the algorithm make smarter decisions about which the path to explore, making them more efficient. Okay, now let's see. Problem solving approaches that use shortcuts to find good solution. Now our aim is to provide practical and quick solution for complex problem. How we can do it? We can use heuristic function. Heuristic function is used to solve complex problems and to give a practical and quick solution via calculating the cost value of their path. It is often used in optimization, search problems and AI applications. Now what the AI applications will be? It will be the Google Maps, like Google Maps. Google Maps is one of the main application that we can see, right? Now, what are the characteristics of heuristic algorithm? It is efficient for large problem spaces. Okay. Now the heuristic, what are the term heuristic here is? Heuristic is an estimate of how close a node is to the goal. Suppose we have a starting node and then we have a goal node. Okay, so the heuristic will be an estimate from the starting to the goal node of how close the goal node is from the starting node. Let's take a real example. In Google Maps, the straight line is better heuristic distance from the starting node to the destination node. That will be what is called a heuristic. Okay. Now, the better the heuristic value, the more efficient our search will be. Now, it will be efficient for large problem spaces. Like suppose we are given a very big graph and we have to calculate the heuristic value or heuristic function from the starting to the goal node. What we will do? We will use the heuristic function formula. Okay. Now, the balance between accuracy and computational time. It also maintains this balance. Now, it is useful in decision making under uncertainty. Now let's see, what is A star algorithm? A star algorithm finds the shortest path through the search space using heuristic function, as we have seen in the earlier slides. Now it uses this term Hn and the cost to reach the node n from the start state, that is Gn. Here the term Gn denotes the actual cost from some node to the destination node. Okay, now this algorithm expands less search tree and provides optimal result very fast. It is also similar to the uniform cost search. The main formula to evaluate the heuristic value is G of n plus Hn instead of Gn. Okay, so now in this A star algorithm, we will use this formula and calculate the minimum path value from the starting node to the destination node via considering more values also. Now, the term Fn here denotes it is the estimated cost of the cheapest solution. What this cheapest solution means is, the Fn will be, suppose we are given a graph and we have to go from the starting to the goal node. This is A, this is B and this is C. So now the Fn value for A node will be, we are given 1, here we are given 2, here we are given 3 and the heuristic values for these are 4, 5 and it is 1. Now let's see. The Fn will be the estimated cost of the cheapest solution. Now the Gn is the cost to reach node n from the start node and the Hn is cost to reach from the node n to the goal node. It uses heuristic function Hn and cost to reach node n from the start state Gn, and it finds the shortest path through search space. Now let's see some advantages and disadvantages of this A star algorithm. It is the best searching algorithm and it is also optimal and complete. It solves complex problems. The major disadvantage of this algorithm will be it doesn't always produce shortest path. Suppose we are given a graph We are taking an example here only. These nodes are suppose A, this is B, this is C, this is D, and this is E. Now we are given some values, and the starting state is A and the destination state is D, or we can say our goal node is D. Now it does not always produce the shortest path. Now as we can see, we are reaching to the goal node via this path, that is A to B, B to C and C to D, within the minimum distance of 2 plus 1 plus 1 is 4. Whereas we are also reaching the destination node through a less number of nodes, or through, we can say, a less number of path, that is 1 plus 6, that is 7. So this is what this term signifies. Does not always produce shortest path. Okay. Now let's see the algorithm step by step. Now the first step is enter starting node in open list. We have to create an open list in which we will put our starting node. Now next we will check if open list is empty, then we have to return fail. Okay, this will be our step 2. Now step 3 is select node from open list which has smallest value G plus H. Here G and H are, G is the actual node and H is the heuristic value. Actual value of the node and H is the heuristic value. Okay. Now it is saying if node equals to goal, then return success. The process will stop here only. The next step is expand node N and generate all the successors. If it is success process, now we have to expand this particular node N and we have to generate all its successors. Now we will compute Gn plus Hn for each successor node. Now next step will be if node N is already in open / closed list, then attach to the back pointer. Now from this step, if node N is already in this open list, again we have also created a closed list. In this algorithm we are having two lists, one is open and the other one is closed. In this, node N is already in the open list, then we have to attach to the back pointer. Now the last step is we have to go to step 2. This process will repeat until we have evaluated all the path, we have calculated all the minimum distance, and we have calculated minimum path from starting node to the goal node with the optimal distance. Now let's see an example. Now this is a start node and this is a goal node. In the start node, as we can see that S is going from A also and S is going to B also. Whereas in this example, we are always given the heuristic values of all the nodes. In this graph, we are also given the actual values also. From S to A, the actual path value. This is called the actual path value that we have studied in this lecture. It is denotes as G of N. Now it will be 1. Now from S to B it is given 4. From B to C it is given 2. From A to C it is given 5. And from A to D it is 12. Now let's see how to solve this numerical. First, we will start from the starting node and we will see from where and where it is going. It is going to two nodes. First is A and the other one is B. Now we will calculate the function fn from S to A and from S to B separately, or we can say individually. First we will calculate S to A. The actual path that is calculated is 1 plus the function which we are using in this A star algorithm is Fn equals to Gn plus Hn. Now the Gn is 1 plus, now what is this 6 value which we have written? In this numerical, always remember we have to take the heuristic value for the child node. We will always take the heuristic value for the child node, that is A. Now the heuristic value given in the numerical is 6. So 1 plus 6 is 7. Now we will take the values for S to B. Now the actual path value, that is G of n, given from S to B is 4 plus the heuristic value for B given is 2. Now we will add it here, it is 6. Now among these two paths, we will see which is the smallest. We can see that S to B path is giving a minimum value 6. Now we will further explore this path. Okay, now let's see. S to B, where it is going? B to C. Is it going somewhere else? No. Now let's explore this path. S to B and B to C. Now S to B path is 4. B to C path is 2. Plus this will be our Gn value plus the heuristic value will be for C. As I have said earlier, we will always consider the heuristic value for the child node. Now the heuristic value for the C is 1. It will be 7. Now again we will see where it is going. From S to B, B to C and C to D. We are reaching the destination. We are reaching the goal node through this path only. Let's calculate the distance. S to B is 4. B to C is 2, which we have written here. And C to D is 3. Plus, now we have got the actual path value. We will now consider the heuristic value. For the heuristic value for D node, that is our child node, is 0. The final answer will be 9. Now we will consider this answer for comparing with the other path values. Now let's consider the another path. Now we will consider this S to A, A to B, S to A, A to C and S to A, A to D. Now we will consider this value. Earlier we were exploring this path S to B. Now we will be exploring this path S to A. S to A is going to B, S to A is going to C, S to A is going to D. First we are seeing that S to A is taking 1 path value, that is the actual path which is given in the graph. Then we will see A to B, what the value is, it is 2. Now we will calculate the heuristic value for B, it is 2. We will consider this value, that is 2. After adding this, we are getting an answer 5. Now we will explore another path S to A and A to C. Now S to A is taking a actual path value 1 and A to C is taking actual path value 5 plus the heuristic value for C is 1. Now the answer is 7. Again we will see this path S to A and A to D. In this we are seeing it is given S to A is 1 and A to D is given 12. Here I have forgotten it, sorry. The heuristic value for D will be plus 0. Now the total answer for this path will be 13. Now among this we have to choose using the heuristic, that which is the minimum to explore further. So as we can see, S to A and A to B is giving the minimum value, that is 5. Now we will explore this path. Now let's see S to A to B and B to C. Where is B going? It is going to C only. There is no outgoing nodes from there also. Now the minimum, the total path calculated for this is 6. It is how S to A is 1, we have considered. A to B is 2, that is also we have considered. A to B is 2. Now B to C we have considered is 2. Now the heuristic value for C is 1. So the total value is 6. Now again we will consider this further, expand further this path. S to A to B, B to C and C to D. Now this path is giving a minimum value 8. Now we will compare this path with the earlier two paths which we have calculated. The minimum value till now we are getting is through this path only. Now we will again calculate another path, that is S to A and A to C. We will go to where the C node is going. It is going S to A, A to C and then C to D. Now the total value via this path is also 9, which is also greater than this path. So the minimum path which we have concluded in this numerical using A star algorithm is S to A, S to A, sorry, this is not right. This will be S to A to B, B to C and then C to D. So this will be our minimum heuristic path value using A star algorithm. Okay, and the minimum path for this will be, the minimum value for this will be 8. Let's look for the another example. Now, in this numerical, we are given this graph and we have given some heuristic values. Again, we have to calculate the minimum path, the minimum value for this graph from starting from the starting node to the goal node. Also in this numerical, we are given what is the start node and what is the goal node. Okay, let's see. Now, in this numerical, as we can see, first we will start from the starting node S. It is going to A and it is going to G. Now, S to A is 1 plus 3. What is 1? It is the path value from S to A and the heuristic value for A is 3. Okay, so the answer will be 4. Now, for S to G, the minimum path value is 10 and for the heuristic value for G is 0. So the path will be 10. Now, among these two, again, I am saying we have to see what is the minimum path. Then we will further explore that path only. Now, S to A to B, A is going to C also and A is going to B also. We will explore both the path and calculate the answer. Now, we will see S is going to A and A is going to B. The minimum path which the answer which we are getting is 7. And through this path S to A to C we are getting 4. Now, we will further explore this path because we are getting a minimum value 4. Now, let's see S to A to C and then C to D. The minimum path answer which we are getting is 11. Now, we will see S to A to C, C to G. The minimum answer is 6, which we can see compare with the earlier answer, it is 10 and it is 6. So, it is minimum. Now, let's explore further this path. S to A to B, then B to D. This is giving us answer 14. The next path which we have seen is S to A to C, C to D and then D to G. The minimum path answer is 7. Now let's explore another path. S to A to B, B to D and then D to G. This is giving us 10. So the minimum path value required will be this path. S to A to C, C to G. It is giving us a value 6. This will be our minimum path in this A star algorithm. I hope you all have understood this A star algorithm in this lecture. Other algorithms will be start in the another lecture.